International Material Research Congress 2025. Poster presentation. Sustainable development of TiO2 for water remediation using sunlight. My name is Misael Castro Chavez. I am a master's student at the Autonomous University of Sinaloa. Introduction. Currently, water pollution is one of the most serious environmental problems for mankind, due to the large amount of wastewater discharged into different bodies of water. The textile industry is one of the main sources of pollution, since it discharges a large amount of chemical waste, mainly heavy metals and dyes. Dyes are generally synthetic compounds with aromatic groups in their chemical structure, which makes them very stable and non-biodegradable. One of the methods that emerges as a new alternative for the remediation of wastewater from the textile industry using sunlight is photocatalysis. Developing sustainable TiO2 by green synthesis using plant extracts. Methodology. 1. Obtaining of pitahaya, morina and acai extracts, using deionized water as solvent and a centrifugation process. 2. Synthesis of TiO2 nanoparticles with pitahaya, morina and acai extracts, using the Sol-Gel method and applying thermal treatment. 3. Photocatalytic activity, using methylene blue to evaluate the degradation efficiency of TiO2 nanoparticles, using sunlight. Results. The results of FTR spectroscopy and TGA confirm the absence of organic material, since there are no peaks or weight losses attributed to the natural extracts, due to the thermal treatment used during the synthesis. Results. XRD patterns and Raman spectra confirm the formation of TiO2 with a crystalline structure in its anatase phase for the pitahaya extract, and a biphasic anatase/rutile structure for the morina and acai extracts. Results. UV-vis spectra of the samples show an absorption around 380 nanometers, characteristic of TiO2, which confirms its formation. The band gap values obtained were 3.25, 3.20, 3.14 and 3.03 eV, for the samples TiO2, TiO2_pit, TiO2_more and TiO2_AC, respectively. The samples synthesized with natural extracts showed a decrease compared to pure TiO2. Results. The results of the photocatalytic activity indicate that the sample of TiO2 synthesized with pitahaya extract presented better results, degrading 100% of the methylene blue, Mb, dye in a time of 40 minutes under solar irradiation. Conclusions. The formation of TiO2 was verified by FTR, XRD and UV-vis spectroscopy. The absence of natural extracts in the synthesized nanoparticles was confirmed using FTR spectroscopy and TGA analysis. By means of XRD, it was possible to identify the formation of TiO2 with a crystalline structure in its anatase phase for the pitahaya extract, and a biphasic anatase/rutile structure for the morina and acai extracts. The obtained band gap values were 3.25, 3.20, 3.14 and 3.03 eV, for the TiO2, TiO2_pit, TiO2_more and TiO2_AC samples, respectively. Finally, the photocatalytic activity of TiO2 synthesized with pitahaya extract showed 100% degradation of the methylene blue, Mb, compared to pure TiO2, which reached approximately 22% degradation in a time of 40 minutes under solar irradiation. The results of solar photodegradation of methylene blue showed that the natural extracts and the thermal treatment used during the synthesis produce modifications in the crystalline structure of TiO2, which significantly increase the solar photocatalytic activity of the material.